Okay, so let's do page 2. So here we have I call them special pairs of angles. So we call them, they're complementary and supplementary angles, which again, they're just special types of angles. So two angles whose measure have the sum of 90 degrees. So let me just get a different color here. So if the sum is 90 degrees of two angles, we call them complementary angles or complements of each other. But if we have two angles and the sum is 180, so it forms a straight angle, then we call those angles supplementary angles, or they're a supplement of each other. So let's look first at the complementary angles. So it needs to add up to 90 degrees, so pretend that's a perfect L. But because I wrote that little box, that denotes that this in fact is 90 degrees, right? This opening here is 90 degrees. And here's my ray and my ray. So if I don't know, I'll just draw, here's my my angle here. So this is my initial side and it's opening up, right? And I'm gonna say that this is, I don't know, 30 degrees. Okay, so if that angle is 30 degrees, then what's the measure of this angle? Well, this is 90 degrees, so 30 plus what is 90? Well, then this guy must be 60 degrees. So we say that that 60 degrees and 30 degrees are complementary angles, right? Or, the complement of 60 is 30. The complement of 30 is 60. Similarly, if we have, let's see, I don't know if I have enough room here, but here we have a straight angle, right? Straight angle, and if I draw a vertex there, here, I mean, this is the initial side, right? And it opens up all the way to this side. So maybe we'll say, right, adds up to 180. And here, if I draw in an angle, let's say, I should have, well, let me make this purple so it's consistent. So if I say I have this angle, and I want to say that this angle is, I don't know, well, okay, let's use 30 again. What if this is 30 degrees? That's a 30 degrees. Then what's the measure of this angle? Well, we know that this angle plus this angle has to give me 180. So 30 plus what gives me 180, or 180 minus 30? Well, that's definitely 150, right? Because 150 degrees plus, that's a plus 30 degrees is 180 degrees, right? So this is a supplement of this angle. So again, just terminology. Okay, so let's move on quickly to vertical angles. Okay, basically you have two lines that intersect, right? Lines. And the opposite angles formed are called vertical angles. So let's see, let me just get a different color here. So vertical angles. So the opposite angle. So this angle is the same measure as this angle. So I don't know, let's say that, okay, we're using, well, let's choose a different degree measure. So let's say this is 40 degrees. If that's 40 degrees, I know this guy is 40 degrees because they're vertical angles, right? They lie vertically, right, opposite of each other. Well, what about, I mean, that's basically what vertical angles are. But also, I mean, we have this angle, and sometimes we, right, denote it maybe with two arcs, because the one arc is, I mean, I just drew one here. It's in color, so it's easier to see. But that guy is the same measure of this guy. And, well, what do we know from above, right? We have a straight line right here, so this is 40 degrees. So 40 plus what gives me that 180? Well, this has to be 140, right? Because 140, right? 140 plus 40 is 180, and this is a straight angle. And then, of course, if this is 140, then this is 140. And the reasoning, again, is the same. 40 plus 140 should give you a straight angle. So that's it for vertical angles. Okay, so here's kind of the meat of the section. What do we mean by eight angles formed with parallel lines and a transversal line? Okay, so let me get some colors here. Let's see. So I'm gonna make my lines. Okay, so this is pretend these are these are parallel lines, right? They don't intersect. I didn't use a ruler or anything, but these are parallel lines. Same slope, assuming the slope is 0, right? And my transversal line, right, is gonna be this guy right here. Okay, there's my two parallel lines intersected by a transversal line. And it creates angles, right? There's an angle here, 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 right? And also here, 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 and here. But instead of saying here, 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 let's give it names. So let's see, let me maybe choose black. So I'm going to call this angle 1, this angle 2, angle 3, angle 4. And let's see, maybe this one angle 5, angle 6, angle 7, and angle 8. Okay, so there's some special properties when we have two parallel lines intersected by a transversal line. The first one is we call this alternate interior angles, and so let me let's see. I'll use I'll use green here. So alternate interior angles means this angle here, angle 4, is equal to angle 6, right? Whatever angle 4 is, if angle 4 is 40 degrees, for example, then we know angle 6 is 40 degrees. So that's what we know. So I'll just go ahead and stop there, move on to the next case, and then I'll explain a little bit more. And hopefully I have room here. Okay, so there's my transversal. And let me get my blue. And there are my parallel lines. And let's see, again, I want to fill this in. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so here I have alternate exterior angles, or I'm focusing on the alternate exterior angles. So exterior, outside. So my green, right, that means this angle, angle 1, and angle 7 are equal. Okay. And so remember, this is called alternate exterior angles, right? They're on the outside, right? This one was the alternate interior angles, right? They're in the inside. And I mean, you can look at this on page 614. It's in your book. I think they just labeled 1, 2, 3, 4, 1 through 8 a little bit differently, but it's the same idea. And the last part, so here's my two parallel lines, okay, cut by a transversal angle. And our last special property here is corresponding angles. And corresponding angles is, right, like this angle is equal to this angle, right? And hopefully it makes sense. I mean, if these lines are parallel, right, and I mean, it's intersected here, this opening is the same thing as this opening. And there are a lot of corresponding angles here. I mean, there's this one, right, and this one, so that would be 2 and 6, right? I mean, there's a bunch. I mean, maybe choose a different color. So we have, right, this guy, we have 2, and we have 6, right? I mean, this is a corresponding angle with this guy. Maybe we can make 3 arcs. That's the same thing as that angle. So that's, again, we have alternate interior angles, right, inside. we have alternate exterior angles outside, and we have corresponding angles, right? This angle corresponds to this angle. Very important properties, especially when you're trying to determine the angle measure in a given geometric figure. So hopefully that makes sense. There's a lot of explanation in the table if you want to go ahead and look at it. And so that's it for this handout.